Okay, so here's question 2. Consider the expansion of this expression. How many terms are there in the expansion? Well, you should know by now there's always just one more than the exponent here, so there are 6. B, find the coefficient of x cubed. Well, there's a long way and a short way of doing this. I'm going to put negative x squared in a bracket, the second term. The first term is third. Now we need to choose exponents here. The exponents have got to sum to 5, but we've got to force out an x cubed in here. Now, how do we force out an x cubed? Because if we put a power of 0 here, the overall will be x to the 0. If we put a power of 1 here, that will give us an x squared. A power of 2 here will be an x to the 4. A power of 3 here will be an x to the 6. So in fact, B, actually, there is no x to the cubed. Okay, so it's not that it's a 0x cubed, there are no x cubes in the expansion. So that's a little bit sneaky. And then, there's another part B here. This is obviously part C. Find the coefficient of x to the 4. Well, here I'm going to do the same thing again. I'm going to write down the second term, which is negative x squared, a little bracket around it. I'm going to write out the first term, which is a 3. Now we've got to power both of these up, so we've got to have an exponent here. We've got to have an exponent here, and here we've just got to force out an x to the 4. Well, it's pretty easy to see that that has to be a 2 here, so therefore this must be a 3 here, and then we need to put the binomial coefficient from the triangle, and so this is 5 choose 2. It's okay if you do 5 choose 3, either of the exponents will work at the start there because of the symmetry of the triangle. So all we have to do is evaluate this. So 5 choose 2, we can go straight to the calculator if you want. This is pretty easy, it's just 5 times 4 divided by 2, so that would be 10. 3 cubed is 27, and then negative x squared gives us a positive x to the 4, so that gives us 270 x to the 4.